Okay, so hi everyone. As I promised that I'm going to start engineering mathematics, for engineers, right? For you can say for GATE 2023, 2024, okay. And engineering mathematics is one of the very important subject if you want to understand technical your core subjects. No matter from which branch of engineering you belong to, right? Whether you are from electronics and communication, or you're from electrical engineering or computer science or mechanical or civil or whatever branch, right? So this subject is very important. So please confirm once whether my voice is audible or not, right, before I get started linear algebra. Okay, so today you will be getting everything, okay, from this session. Okay, in fact I will not make this session very longer, right, so that you could also digest the concept, because it's 11:30, okay, and in fact now it is going to be 12 as well. So please confirm, whoever is watching me live, they can confirm whether my voice and everything is okay, so that we could get started. Yeah, hi Raviteja. Yeah, great. So my voice and everything is audible, and yeah, great. So we shall start linear algebra, okay, and what you're going to get from this, okay, that you will be getting all the content on linear algebra, okay, and there would be different concept, right? Whatever you have learned, the conventional way of learning will be eliminated today, okay. So yeah, hi Raviteja. Yes, so okay, so let's get started, right? Okay, great. So let's get started here. So this for electrical engineering as well as for you can say for computer science and for any branch you talk about, right? So this is one of the very important subject, okay, so you have to keep this in mind. So this is going to be my blackboard, okay, where I will be discussing about linear algebra. So in linear algebra, what we are going to learn today, we need to understand that why we are studying linear algebra, okay. Many people will understand that, okay, after all matrices is there, okay, but yeah, matrix will come into picture definitely, but we have to understand what is the fundamental problem of linear algebra. So my question is, what is fundamental, okay, fundamental problem of linear algebra, right? Okay. Why we want to study linear algebra, right? So you have to always keep in mind that if we want to find, if we want to solve this system of linear equations, okay, to solve system of linear equations, okay, system of linear you can say linear equation, the fundamental problem of linear algebra is to solve system of linear equation, system of linear equations. So these things you have been doing since many years, you can say, right? You started with the linear equation in one variable, okay, you started with linear equation in one variable, okay, in class 8th, right? One variable, okay, you started from class 8th, you can say, and there was like x plus 5 equal to 7, so you can find out x equal to 2, okay. This is the linear equation in one variable, okay. But if as we go ahead in the class 10th, right, so we solve what we solve pair of linear equation in two variables, right. So we talk about pair of linear equation in two variables, right, okay, two variables. So let me take some of the equations, so we will take pair of equations, okay, and we will try to solve that, okay. So let's take linear equation, pair of linear equation, guys, and Sir, for finding solution for system of equation. Yes, great. Yes, Ravi Teja. So you are correct. So let's consider here a pair of equations. Okay, just I am going to start with pair of equation. So the pair of equations are x plus 2 by equal to 4, right, and x minus by equal to, you can say, 1, right. So these are the pair of equations, and you can see there are two variables. So you can consider yourself you are in class 10th now, right. So how can you solve this equation, these pair of equations? There are two equations. Okay, so there are two equations and you can say two unknowns, or two variable we call it, right. There are two variables and two equations. Okay, so this can be written like this. Okay, if we want to represent these two equations in terms of matrices or matrix, right, what we can do here is we can put the coefficient of these variables, right, in the form of rectangle, right. So here I am writing 1, this is 2, this is 1, this is minus 2, right, and this is going to be the coefficient of matrix, we call it. Okay, coefficient of matrix, and this is your x and y, you can say. This is column, or you can say column vector, you call it, right, column vector, or just write this is x component, this is y component, and this is one component, this is second component, right, and this is right hand side, that is 4 and 1. Okay, so this is what the matrix representation, this is the matrix representation, and coefficient of matrix we write like this. Okay, so we can write Ax equal to B format. Okay, so whenever you see system of linear equation, whether it is two equations, two unknown, or m equation, n unknown, m equation, n m unknowns. Okay, so you can write always in this format, Ax equal to B. What is the meaning of Ax equal to B, right? These things we will understand. Here what we are doing here is we are multiplying matrix with the vector, right? So matrix into vector. Okay, you are getting vector only. Okay, so matrix into vector we are doing. So this is what the linear system of linear equation is. Okay, so this is what the school problem. Okay, we have got two equation and two unknowns, so we can solve that. Right? So x plus 2 by equal to 4, x minus by equal to 1. So how can we solve this? So we have learned in class 10th one method. That method is known as elimination method. Yeah, elimination method. Okay, elimination method by which you can find the solution of equations. Okay, system of equations. So just you can subtract this, so it is plus and this is minus, so you can. Okay, so what is the meaning of elimination here? You will delete one variable and you can find a second variable, then substitute back, okay, whatever the variable value you have got. So this is 3y and this is your you can say 3, so your by equal to 1, right? You have got the by equal to 1, right? Ravi Teja is saying yes. Hitik, yeah, second row last element should be minus 1. Let me check. Yes, great. Here, yeah, thank you, Hitik. Yes, great. So this is the coefficient matrix and it has the coefficient minus 1. Perfect. So yeah, it's okay. So this is by, you have got by here, right? So you can plug in the equation, any equation you can plug and you can find out. So what is the meaning of elimination here? Elimination meaning just you are deleting one variable and finding out second variable and plugging it back. Okay, so you can plug here, this is first equation, this is second equation. So x plus 2 equal to 4, so your x equal to 2. So these are the solution of the system of linear equation, right? This is one method. Okay, ये आपका एक मेथड हो जाता है. यस, x इक्वल टू 2 एंड y इक्वल टू 1. यस हितिक, करेक्ट. तो there are various method of solving system of linear equations. Okay, so this is one method which we know, elimination method, from our 10th class. okay, pair of equation in two variables. We can also have pair of many equations, you know. In fact, you can have m equations and n number of variable as well, right? Then you can't solve that kind of a system of linear equation, okay? That is not that easy, right? So we will take a look how we are going to solve, right? So you can also solve this these two equations with the help of substitution method. You can also solve this equation with the help of graphical method. I hope you might have find out the solution using graphical method, okay? Graphical method, okay. So this is what the basic is, okay? This is all about school basics, right? But what we are going to do here is we will be solving, in fact, we will be talking about graphical method as well, right? Graphical method as well. Graphical method of solving system of linear equations, okay? So what we have got here is we have got Ax equal to b, right? So the matrix into vector, we are getting vector only, right? So this is basically your vector. Remember, this is your vector, okay? Vector will be having component, okay? You can say component 1 and component 2, and here matrix will be having coefficient, okay? So two equation, two unknown means it is a 2 by 2 matrix, you call it, okay? So it is A11, A12, A21, A22, right? It is very easy matrix, okay? 2 by 2 matrix, or you call it square matrix as well. And this is again one vector only. So you are getting matrix into vector, you are taking the multiplication, so you are getting vector only, right? So this is one way of representing system of linear equation in two variables, okay? So let me also tell you one of the very important format, that is x plus 2 by equal to 4 and x minus by equal to 1. So you can write this as x times of 1 and 1 plus by times of a vector, right? That will be 2 minus 1 equal to 4 and 1. So this is known as, guys, this is known as, in fact this is read as, you can say, linear combination of column vectors, okay? Column vectors, what we call it? Linear combination of column vector. This word is very, very important. Linear combination of column vector, okay? So this is one new format for you, okay? These things हम लोग स्कूल में नहीं पढ़ते हैं, right? हम लोग ये सारी चीजें नहीं पढ़ते हैं. So Hitik is saying by drawing graphs of two equation and then finding the point of intersection by graph. Yes, very good. Yes, and by intersection of two lines of equations, yes, we can have the solution of system of equation. But we are talking about linear algebra, right? So we need to understand this. So this you have to keep in mind. This is new to you, okay? You can write like this, okay? So this is for different value of x and y, you will get this new vector, right, which is also a column vector, okay? So we read like this. If I am writing like this, alpha x plus beta by equal to something, you know, you can say something here 3. What is this? You can say this is the linear combination of alpha and beta, right? Linear combination of alpha and beta for different value of x and y, you can say. So here linear combination of column vector, it is known as, okay? Please keep this in mind, okay? We will discuss, right? So if this is equation number 1, this is equation number 2. So if I am going to draw, in fact plot this, okay, first equation. So take equation number 1, okay? Equation number 1, right? What is that? X plus 2 by equal to 4. So how we are going to plot? You know that there are two variables. So this is x and this is y. So if I am going to put x equal to 0, right? So y is going to be 2. So y will be 2 here. And if y equal to 0, so x is going to be 4 here, right? So you can say this is 4, right? So you can say 4, 0, and this is, you know, 0 and 2. You can join these two lines. these 2 points, right? So you're getting a straight line with this. Okay. In linear algebra, we will call this as row picture. Okay, this is row picture, guys. Okay, this is row picture. Remember always, this is a row picture. Keep in mind. Okay, in 10th class, what we study, we plot this, right? We only find out 2 points and we are drawing one straight line passing through them. Okay, so all the point will lie on that line only, right? So this line is known as row picture. Okay, so this is for row 1. So this is for row 1. So this was row 1. You can understand. You can see here, if I show you the matrix, coefficient matrix. Okay, let me go back and show you this matrix, right? So this is row 1. Okay, and this is row 2. Okay, so if this is again, this will give you row 2. Okay, and this will give you row 1. So how to represent in the xy plane? You can say row of a matrix can be drawn or represented by this. Okay, by a straight line passing through 2 points. Okay, yes. So we can take second equation as well. So what was the second equation, guys? Second equation is x minus y is equal to 1. X minus y equal to 1, right? This is second equation. So you can easily plot this. I think it will be x equal to 0, then y equal to minus 1 here, and y equal to 0, x equal to 1 here. So it is meeting like this. At this point it will meet. It will meet here, right? Yeah. So these 2 lines are intersecting. So this is a point of what? This point is the meeting point where the solution will exist. Okay, you can say solution will exist. So this point will be basically 2 and 1, right? This is, you can say, this is 2, this is 1. So this is the solution of system of linear equations. Okay, so this is the row picture again. So we have seen 4 points till now. One is the fundamental problem of linear algebra is what, guys? Let me come back to the screen. Okay. Yes. Let me come back to the screen. So we have seen 4 major points. Okay. What is the fundamental problem of linear algebra? To solve system of linear equations. They can be m equation, m variables. Okay, there can be m equation, number of equation will be m, number of variable will be m, right, or n, you can say. And already we have seen, so we must start with something what we know already, right? Let me read your comment as well. So guys, then what we have seen, we can write those system of linear equations in terms of Ax equal to b, right? The matrix into the vector will be the vector. Okay. And one more important representation you have seen, the linear combination of column vectors, right? So there are 2 columns. Okay, if there are 2 equations, 2 unknowns, right? So x times a column vector plus y times a column vector is equal to the column vector itself, right? The right hand side. Okay, so by choosing different value of x and y, you can get the third column. Understand? Okay, so we will see how to add these 2 columns and get the third column. Okay, so here I am saying that the column is a vector. Okay, and if that is a vector, so it would be having components. Okay, so it is having 2 components, right? You can say if you are considering 2 equation and 2 unknowns, so there would be 2 columns, right? And there would be 2 component as well in each columns, right? So I hope this you have understood. Then what we have drawn here is we have solved that system of equation using elimination method, right? So elimination method is what? Deleting one coefficient, or you can say one variable, sorry, and then finding second variable and plugging it back. Okay, that you have understood. Next we have seen that how to represent any straight line equation on the xy plane. Okay, understood. So that was the row picture. This is how we represent row on a xy plane. Okay, so I think till this point the life is very easy. okay. But suppose there are m number of equations and m number of unknowns, then what you will do? You don't have any options, right? You will have to use again the matrix, and you will have to go for matrix representation, and using matrix concept, okay, you have to solve the problem, right? So I will tell you how to find the solution of system of linear equations if there are many equations and many unknowns, okay. There are few methods which I am going to discuss. Yes. So guys, if you would be having any kind of doubt, you can anytime ask, okay. My speed is slightly higher than as I expect, right? Okay. So this is a row picture. Let me show you how to, in fact represent column vectors, okay, column pictures on the xy plane. So now I will talk about column picture. This is very interesting. Column picture. Okay. How to represent column in the xy plane. So what I have told you that x plus 2y is equal to, let me on Now you can see here, now we will talk about column picture, right? So x plus 2y equal to 4, okay, and x minus y equal to 1, okay. These are the two equations. So I am going to write them in terms of what? Linear combination of column vectors. So you see here, this is x, so 1 and 1, okay, these are the coefficients, and plus y times of column vector, that is 2 and minus 1. These are the two columns, okay. If you see the matrix, the coefficient of the equation, so it is 1, this is 2, 1 minus 1, right? So this is your column number 1, this is your column number 2, right? So x and y. So I am writing in this format, okay. So whenever you see system of linear equations, always consider this is ax equal to b format. So v can be 0, v cannot be 0, okay, it depends, we will see. So this is basically 4 and 1, right? So this is your column number 1, this is your column number 2. This is your column number 2, and this you will get as a resultant column, right? This is resultant one. You can say resultant vector. So column vector, this is column vector 1, this is column vector 2, okay. Now it is 1 1, right? So let me put in the xy plane. So this is your x, this is your y. Where is 1? Where is okay, so this is 1, you can say, and this is 1, right? Okay, so you can say this is one vector here, right? It is having 1 and 1, right? Okay, this is one vector. This is how we show, this is how you can also write 1 and 1 like bracket and 1 and 1, okay. But don't consider this is row, okay, this is column only, right? Using parentheses, okay, or using this kind of a big bracket, okay, these are two components only, 1 and 1, there are two components, okay. So you can see, so let me write here, okay, this is y and this is x, okay. As we go, so this is first vector, this is first column vector. Can we go ahead and check second vector? 2 and minus 1, right? So this is 2 and minus 1. So you can write this as 2 and minus 1. These are the two coordinates on xy plane. So 2 is this is 2, okay, and y is 1 here, right? You can say this is going to be the second vector, right? So you can say this is 2 and this is minus 1. Yes. Okay guys, I hope this makes sense to everyone. So have you understood how to represent columns on a xy plane? Ravi Teja, Hritik, and okay, there are 4 guys I think watching the session, so they can also ask the question. So I hope you guys have understood this, how we are representing, right? So you can say these are the coordinates only, right? So after all, I am calling column as a vector, so this is column vector, right? 2 and minus 1. You may be wondering that what is row vector then? Yes, what is row vector? If this is a column vector, so why I am not saying this is a row vector, right? This is not a row vector, guys. Remember, this is not a row vector, Okay, what is column vector, what is row vector, we will talk about that. So if this is a column vector, so the transpose of column vector is known as row vector. Remember always, transpose of column vector is the row vector. Okay, always keep this in mind. The transpose of column vector is known as row vector. So now we have got two vectors. Okay, we have got two vectors. So how to add two vectors? Okay, you must know that. Let me show you. I will come back into this slide. Wait, but let me go back again to the school. है ना? So how to add two vectors? Suppose you have got a vector. Okay, and suppose you have got one b vector here. So how to add these two vectors? So what I will do here is, in case of vector, if I am going to shift this vector parallelly, right? So I can shift this vector here as well. Okay, nothing is going to change. Its magnitude is going to be same as well as the direction as well, right? And you can also shift this guy here, right? So this is the resultant vector, right? This is the resultant vector. This is how we add two vectors. This is b vector. So you can find the third vector c. Okay, this is how we do. So let me get back here as well. So you can see I want to add 2 and minus 1 and 1 and 1, right? Okay, so what you can do here is you can just multiply the value of x and y, because you can see here this is the linear combination of x and y. You have got x equal to 2 and y equal to 1, right? So you can multiply with the vectors. Suppose you have got one vector here, right? Suppose this is a vector a. If you are multiplying with constant, okay, suppose you are multiplying with 2 into a vector, right? So what will happen here? The vector direction will be same, only the magnitude is going to be differing, right? Magnitude will be increasing here. Okay, you have to understand that this is a column vector 1. Okay, the column vector 1 where we are multiplying 2. So you can multiply this. So this vector will be here, you can say. Okay, 2 times of that, right? So I'm just taking, you can shift also this side, so it will be like this. So this is your, you can say this is 2 times of 1 and 1, right? And you are multiplying with 1, so it will be same only, right? Now you can also shift this like this. So what is the resultant vector, guys? Resultant vector is going to be this. Okay, so this will be basically the third vector, which is this 4 and 1. I think you are able to visualize this is 4 and 1. You can say at this point this is 4, right? And here it is 1. So this is how we add two column vectors. Understood? Yeah, triangular and parallelogram. Yes. So everything is basics only, guys. Nobody discussed these things. Okay. So these are very important concepts one should know, because in GATE syllabus you will find there are topics like vector space, there are topics like what is basis, what is dimension. Okay, so many topics are there. What is column space, what is null space. Okay, till now you were studying linear algebra as pure matrix. Okay, pure matrix, but matrix can be studied with the help of vectors. Okay, because in future we will study about eigenvectors. Okay, so there are many vectors and there are eigenvectors. So what is the difference between eigenvectors and whatever vectors you know? Okay, so these things you have to keep in mind. So I hope this makes sense, how to add two column vectors on xy plane. तो सबको समझ में आया यहाँ तक? हितिक, रवि तेजा, and there are 5 guys now watching us, right? So they can also ask question if they have any doubt, right? And these sessions are, guys, high sessions, okay, where you will be able to get new concepts, okay, new concepts, and this will also form a basis for artificial intelligence as well as, you know, machine learning if you will go for MTech. Yeah, yes, Quincy, great. So this is how we add two vectors, keep in mind. And now you understood what is row vector. Row vector will be the transpose of the column vectors, right? So never in the question if they have mentioned like this 1 1 1, right? So don't consider this is a column row vector, right? This is a column vector, right? Okay, this will be, you can write this as 1 1 1 like this. Okay, good. So we have got two equations, two unknowns, and we have done we found out with the help of elimination method. But suppose there are m equations and m unknowns, then what you will do? But there are m equations and one, okay, and unknown, then what you will do, right? So you have to understand, okay. So there you will find, if I will take two equations, okay, so you are getting like we have considered x plus 2y equal to 4. What was that? Yeah, 4, right? So 4 and x minus y equal to something 1. So they are intersecting at a point, right? They are intersecting at a point somewhere like this. Okay. So we are getting what? We are getting unique solution, you can say. We call it unique solution. Okay. We call it unique solution. Okay. We call it unique solution. Okay. And remember, if there is a solution exists, okay, if solution exists, so there is one important word, we call it, these two equations are consistent. Okay. These two equations are consistent. So these kind of words you will find always in linear algebra, right? Unique solution means you are getting one solution that is 2 and 1, right? And these two lines are crossing, intersecting at one point. Okay. Suppose I will give you some equations again, and they will not intersect, right? They will not intersect. So let me take one. Let me consider one equation. Okay, so that they will not intersect. Okay, so suppose this kind of equation is there, x minus y equal to 1 and minus x plus y equal to 2. And if you are applying system of elimination methods, you will find that, yeah, so both are getting cancelled and 0 should not be equal to 3, right? So it is inconsistent, right? It is inconsistent. What is the meaning of inconsistent? If you found that the equations are inconsistent, means no solution directly, means no solution. Okay. If there is no solution, means that is inconsistent directly, you can say, right? System of equations are inconsistent. Okay. And yes, Hitik is saying correct, if they are parallel, right? So you can draw the okay, these two equations. Okay, you can draw the row picture. I will call it row picture, right? So suppose this is y and this is x. Okay, so I'm drawing them. You will find like this. Okay, some equations you will get. Suppose x equal to 0, so y equal to will be okay minus 1. Okay, so x equal to, suppose you can put here, right? So x equal to 0, y equal to minus 1. So x equal to 0, y equal to minus 1 here. This is a point. Okay, 0 and minus 1. And you can put y equal to 0, so x equal to 1. So this is a point, right? So this is one line you are getting. This is row 1, you can say row 1. So whenever they will give you equations, okay, system of equations, so you have to put them in the form of ax equal to b always. Okay, these are the basic thing I am discussing. But when it comes to linear algebra, so either graph you draw and check, or you can write in terms of system of equations, in terms of matrix, right? But this is 2 by 2, or you can say 2 equations, 2 variables. So you are able to solve with the help of graphical methods and with the help of elimination. But if there will be many equations and many variables, so never try this. Okay, otherwise it will take a lot of time. I will tell you what method you have to follow. Okay, so you can also do this. So x equal to minus 2 if y equal to 0, and yeah, so this is the equation here. I mean, this is the row 2. You can see these two lines are parallel to each other, right? Okay, yes. So the solution will not exist, right? So solution will not exist. So this is not having any solution. So it is inconsistent. In the option, if question is present like that, this is inconsistent. So yeah. Now let us take one more, okay, where you can see here if line do not intersect, a line do not intersect, okay, if line do not intersect, so there will not be any solution and it will be inconsistent. Okay, so let me take one more very good equations where you will find that all the points will be on the same line. Okay, so suppose this is the equation here, x minus by equal to 2 and minus x plus by equal to minus 2. Okay, so these equations are same only, right? You can see if you take minus sign here out, so these two equations are same, but they are moving different in the different directions, right? Okay, so you can see here if these two equations are same, means the line will be overlapping to each other, right? You can see both lines are lying on a same plane, you can see, and the directions are different, right? One line is going like this, one line is going like this. You can see you take minus sign out here and you will get the same, right? So what is there? There are many points, many, okay, they are not intersecting but they are overlapping to each other, right? So both are the same equations and any point on the line is a solution of given system. Okay, so you can write this very important statement. Both are the same equation. Okay. Any point on the line is a solution of given system, right? What does it mean? So there will be many solutions. So this is the case for many solutions, right? This is the case for many solutions. So you have got three things. Okay, let me come back. Yes, Hrithik is saying infinitely, yeah, coinciding, great, infinitely many solutions. Yes. So guys, we are discussing what? We are discussing basically the what? The linear algebra, right? Till now we are in school, okay? Whatever we are discussing, plotting, any straight line equations involving two variables, okay? So we are plotting what? Row picture, you can say, right? Consider row picture. Now we will take some, kind of three equations and three variables, okay? And then we will try to find the solution. So there will be some method that you have to keep in mind, and you will also get to know some of the new words, right? So please accept that, and that is going to decide everything. Okay, so because you know that if there are many inputs, right, and then there will be many outputs, right? So then solving by graphically will be very difficult, right? So there can be n dimensions as well, we will come across. Okay, here 2 by 2 matrix is there now, I mean you can say two equations and two unknowns, so it is two dimension, okay, problem. There can be n dimension problem as well, right? Suppose there are four variable, four unknowns, so four dimensions, right? Because the column vector would be having four components, right? Okay, right. So vector interpretation is very important in linear algebra. Okay, all the time you have to keep in mind vector interpretation is very important. So let me discuss what are the methods are available to solve any system of linear equations of any number of equations and number of variable if they are many, right? Okay, so how can we solve them, right? So let's go ahead and see that, right? Okay, so there are methods, guys. I hope you have understood, right? So how to solve system of equations, right? System of linear equations. Okay, suppose you have got the form Ax equal to b in the form matrices, right? So there are few methods. Okay, in fact in network theory also you will find in network theory, suppose there are 3 loops, okay, 3 meshes, and you are writing mesh equations, you will get 3 current. Okay, then without using calculator you can't solve, right? You can't find okay, so there are methods like okay, the very first method is which we will not prefer, in fact, okay, in this course, that is known as method of you can say determinant, okay, which is also known as Cramer rule. Have you heard about Cramer rule? Cramer rule, suppose there are 3 equations and 3 unknowns, I mean 3 meshes are there in the network, okay, and you have written 3 equations, right? So solving 3 equations is very difficult, so we go for Cramer rule only, right? And then matrix inversion form, okay, so matrix inversion form or matrix inversion method, you can say. So how we solve this? Like we have got Ax equal to b, so we can say that we can find x, okay, by finding the inverse of the matrix times b, right? Okay, so what is the inverse of the matrix? You must know, right? Inverse of the matrix is nothing but the adjoint of A upon the determinant of the matrix, and determinant of the matrix should not be equal to 0. ये भी आपको पता होना चाहिए, ठीक है? So those things we will discuss. Okay, what is the determinant of the matrix if that is going to be 0? So that is known as singular matrix. Okay, so सब कुछ हम लोग discuss करेंगे, अभी बस आप समझो, ठीक है? And the third method, which is my favorite method and आपकी favorite method, which you know already, the Gauss elimination method. तो जो गेट एग्जाम में हेल्प करेगा, दिस इज, सो आई एम गोइंग टू पुट स्टार हियर, एंड गॉस एलिमिनेशन मेथड इज वेरी वेरी इंपॉर्टेंट. ओके, yes, Hithik, Cramer rule you might have seen in network theory somewhere, they use all the time, right, to find currents. Okay, there are 3 equations, 3 unknowns. Okay, so we use all the time Cramer rule and all, but now you are not in semester, you are preparing for gate, so follow Gauss elimination method, right? Elimination method, whatever you have done in 10th class, now the same story will be here. Okay, the same thing will be here, guys. Okay, बस आपको समझना है कि that will be known as, you know, row operation or column operations, right? We will apply some row operations. Okay, तो आपको लगेगा कि अरे ये सर क्या कर रहे हैं, राइट? तो एलिमिनेशन मैथड वी विल यूज वेयर, you know, this kind of operation will be there, like row operations or a column operations, right? So we will reduce that matrix so that we can solve that all those equations, right? So in Gauss elimination method, what we are going to do, okay, my favorite is Gauss elimination method. Okay, remember, my favorite is Gauss elimination method. So you have to follow few points here. So I will take some example here directly and explain. Okay, so in Gauss elimination method, suppose we have got equations, right? Suppose you have got 3 equations here. You can say x1 plus x2 plus x3 equal to 4, right? And 2x1 plus 3x2 plus x3 equal to 7. Okay, x1 plus 2x2 plus 3x3 equal to 9. Suppose you have got 3 equations. Arey baap re, it looks horrible, right? Converting into echelon form. Yes, great. So these names are wonderful. Yes, we will come to know, because this is my first class, so I should not say that echelon and everything, otherwise many students will get confused as well, right? So I will discuss what is echelon form, what is row reduced echelon form, what is all about that. Don't worry. So let me be very general. Okay, if somebody doesn't know anything, they can also understand entire lecture, right? Okay, suppose you have got these 3 equations, so you can write immediately whenever you see equations, system of equations, you should write in the form of Ax equal to b. Immediately please write it. Okay, so we can write this as A, okay, A matrix, that is the coefficient matrix. So it is 1 1 1, it is 2 3 1, it is 1 2 3, right? And here it will be x1 x2 x3, that is column vector, and this is 4 7 9. Okay, 4 7 9. You see here, I'm going to, this is your A matrix and this is your B matrix. So what I will do now is, see, what I will do now is, I will take B here from here and combine with A, right? So see here, what I'm going to do here is, I'm going to write A matrix. So what is A matrix? 1 1 1, right? And 2 3 1 and 1 2 3, and I'm going to combine here with B, right? 4 7 9. Okay, so this is known as what? This is known as augmented matrix. Okay, augmented matrix. Okay. Now you will think, why I'm doing this? So guys, can you tell me why we go for augmented matrix here? See, we are doing manually everything, right? But in MATLAB, if you see now, so first your MATLAB software will solve this, the right hand side, that is A matrix. Okay, but in our case we can do we can apply the operations in both. Okay, so just we are writing in this format, A given B, right? You can say A 1 1 1 2 3 1 1 2 3, this is A matrix and this is B. So we are tacking B matrix on A matrix, that is known as augmented matrix. Okay, the very first step you have to do this, right? I mean second step, right? This is the first step you have to do always whenever you have been given system of equations, and then second step is augmented matrix. Okay, now what you have to do here is, okay, what you have to do always keep in mind, you have to choose the pivot. Okay, this is known as pivot here. So what is pivot? You have to choose one pivot. Okay, pivot should be non-zero, right? So this is, you can put circle or rectangle, what, square, whatever. So this pivot should be this pivot should be what? Non-zero. Okay, so it is 1, it is perfect. So you can say 1 is there, 1 1, and this is 4. Now what you have to do, below this pivot, all these elements, all these coefficient of the matrix should be 0, right? Below this pivot only, you see. So it is 2, it is 1, so you have to make it 0 by any means, right? By applying any row operation or what. So you can, what you can do, you can multiply in row 1 2 and subtract. So it is 0 here, right? It is 1, it is minus 1. Okay, so I am applying R2 minus 2R1. So needless to write again R2 minus 2R1. Okay, first of all you have to choose one pivot. So R2 minus 2R1. So you make it 0 0. This is 1, this is minus 1, and this will be minus 1, right? Yeah. And next you have to make it 0 again. So you can apply R3 minus R1 directly. R3 minus R1. These are the two row operations you are doing. Okay. So now you might be thinking, sir, it is new concept. No, it is not a new concept. You are deleting the first variable x1, you are deleting x1 now. Okay, from second and third, right? So you are eliminating only. So this is what you have done in class 10th, right? But here in terms of matrix, we are saying row operation is there. Okay, so why we are applying row operation? In school days we had no knowledge about why we are applying row operations, right? लेकिन अब यहाँ आपको समझ में आ रहा है कि रो ऑपरेशन का मतलब एलिमिनेशन ही है और कुछ नहीं है. तो हम लोग रैंडमली इसलिए रो ऑपरेशन लगा देते हैं कुछ भी, राइट? तो यहाँ पर आपको याद रखना है कि दिस पिवट यू हैव टू कंसीडर, एंड पिवट शुड बी व्हाट? इन ईच कॉलम वन पिवट विल बी देयर, यू हैव टू सी हियर. तो this pivot should not be 0, right? So below this all the elements should be 0, right? You have made it 0. This is 1, this is 2, and this is 5, right? Now, so this pivot is done, right? Now you come to here, the second pivot, right? Okay, so second pivot is what? You can see below that 1 is there, so you have to make it 0 again, right? So let me go back let me go to next slide here. So I'm saying that this is 1 1 1 and this is 4, right, and this is 0 1 minus 1 minus 1 0, 1 2 and 5, right. So very easy, right. So this is done. Okay, below this pivot all the elements are 0, it's okay. Now take this pivot, right, so all the elements should be 0, so you can make it 0. How you will make it 0? You can apply again, you can say that R3 minus R2 you do, just subtract R3 minus R2, so you will get 1 1 1, this is 4, this is 0 1. So whatever pivot, wherever the pivot is present, right, don't apply any operation, right, here only you have to apply. So this is minus 1, now it became 0, it is 0, and this will be what, 3, this is 6. Okay, so how many pivots are there now? You see, this is pivot column 1, this is second pivot in the column 2, there is a third pivot also, but there is no element below this pivot, right. So now it is done. You have applied your Gauss elimination, right, you have applied your Gauss elimination. Now you can what you can do here is you can translate into AX equal to B format again, right. So I'm just translating this. So this will be x1 plus x2 plus x3 equal to 4. Second one is x2 minus x3 equal to minus 1, and this is 3x3 equal to 6. Okay, so you can see here now you try to find x3 value from here, from the third, right. Okay, you can find out x3 value from here, then plug here, then plug here, right. So you will get x1 x2 x3 value, right? This is what the Gauss elimination method. So in Gauss elimination method you have to reduce the matrix. Okay, you have to consider the pivot and reduce the matrix and go for back substitution, right, back substitution, right. Okay, this method is very back substitution, right, so that you could get back x1 x2 x3. This is how we find out the solution of system of equations, right. Now you see here how many variables are there and how many pivots are there. Okay, that is very important. You might have heard the word rank of a matrix. Okay, rank of a matrix, we are going to talk about that also. Okay, so how many pivots are there? Can somebody tell me how many pivots are there? So you can find out from here x1 value, right, you can find out x2 value, you can find out x3 value, right, that will be the solution here. Okay, so let's comment here whether there is a unique solution, there is a many solution, or there is no solution, right. So how many pivots are there, guys? So you can say that number of pivots, okay, is equal to number of unknowns in this. Okay, you can count here, there are how many number of unknowns? 1 2 3, and how many pivots you are getting? 3 pivots, right. So you are saying that number of pivots is equal to number of unknowns. Okay, so if this will happen in your if this will happen in your solution, in your reduced form, right. Okay, this is also known as, you can see this looks like a upper triangular matrix. Okay, UTM, right, upper triangular matrix. This is also known as echelon form, right, you can say echelon form. Okay, so we are reducing rho here. Okay, so rho reduced echelon form. Okay, so here you can see this is echelon form, right, echelon form, and it is in the form of UTM, upper triangular matrix, right, because all the elements below this diagonal is 0 and above they are non-zero, right. So yes, so number of pivots equal to number of unknowns, so it is known as unique solution. So there will be what? Unique solution will exist. Okay, unique solutions. So what is the meaning of unique solution? You will get x equal to 2, x3 equal to 2, then you will find from here x2 and everything, right. So this is the unique solution. Okay, and you can say you will get all the system of equations are consistent. okay. So only one solution you will get when number of pivots equal to number of unknowns. But one more thing you have to see here in this echelon form. If this pivot, okay, in B, okay, in B this should be non-zero and this should be non-zero, then only you will get unique solution, remember, okay, then only you will get unique solution, okay. So number of pivots here is equal to number of unknowns, right? So you are getting unique solution. Suppose this is 0, okay, and this is non-zero, then you will not get any solutions, right? So no solution will be there. So let me write all those format so that you could keep in mind. So sir, what happened if any yeah, definitely I'm going to come back. Yeah, I'm going to talk about that, don't worry. Yes, sure, because I was talking about unique solution now I will take the format and you will understand. Yes, very good doubt. So for unique solution, remember always, this is very important statement. For unique solution, each column should have pivot, okay. Each column should have pivot. I hope this makes sense to you. If you want unique solutions, so suppose in the options there are unique solutions, okay, this term is present, okay, unique solution. So each column should have pivots, okay. If any column should not have pivot, so you can eliminate that options. Unique solution will never exist, okay. This is very important, okay. Suppose one let me take one reduced form only, okay. Suppose you have got this kind of a reduced form, right? 1 1 1 0 1 minus 1 and 0 0 0, right? And this is 1 4 minus 1 6, okay. So what you can comment now? Suppose you have got this after reducing after applying elimination method. So you can see here, first of all, number of pivots are not equal to number of this. You can see there are 2 pivots only, okay. There are 2 pivots and there are how many variables, right? There are 3 variables, okay. But one important fact you have to see, if this is 0 here, if this is 0, right, so it cannot be the pivot, right? If it is 0 means it cannot be the pivot, okay. But right side you see here, rightmost column has a pivot, okay. Rightmost column has, okay, pivot, okay. Therefore no solution will exist. Therefore no solution will exist. You don't have to think about anything, guys, okay. You don't have to think about anything now, okay. If this kind of a situation is there, you can see here number of pivots is less than number of unknown, okay, it's fine, okay. But this has pivot only, right? You can say in B, okay, there is a non-zero value here, but this is not 0, okay, this is 0 here, okay. So if you will convert into in terms of variable, if you will write, so it will be equal to 0 equal to 6, then you can say x2 minus x3 equal to minus 1. So this is wrong, okay, this is inconsistent, right? Okay, so if there is an inconsistency in the system of linear equations, what you can say, guys? If there is an inconsistency in the system of linear equations, what you can say? No solution will exist, okay. So when you are reducing and if you have got in A matrix only 2 pivots and last row is entirely 0, okay, but your B matrix, whatever B was there, I mean whatever column vector was there, what you have tagged on in the augmented matrix. So if if this number, okay, if this pivot, you can say, okay, in this column this element is not 0, then there will not be any solution. You can also see here this is not possible, okay, 0 cannot be equal to 6, right? Okay, so number of pivots is less than number of unknowns, right? This is one of the very important concept, right? So you can understand always that so you can also just forget about this, only keep in mind this. Okay, what you have to keep in mind for no solution? If this is entirely 0 and if there is a pivot, right, in B column, so you can say that no solution will exist. Let me talk about if all all the elements are 0, you can say 1 1 1 in B, okay, 0 1 1, and this is 0 0, right? And suppose this is you can say 4 minus 1 0, like this. Okay, this situation also you can get, right? This is A given B. Okay, so now you can see how many pivots are there. Pivots are 2, right? So the situation is, okay, so you remember I told you that number of pivot is less than number of unknowns. Okay, this is not the essential condition. Remember, number of pivots is less than number of unknown. It does not mean that there will not be solution. Okay, there can be the solution. Remember, number of pivots is less than number of unknowns. Yes, there are 3 unknowns, okay, and there are 2 pivots, right? But still the solution will exist. Okay, but still the solution will exist because it is entirely 0 here. Okay, there is also 0, there is also 0. So you can say that the systems, or you can say equations, are consistent if you write the equations. So equations are consistent. Okay, but what you can say, whether there will be unique solution or you can say many solutions. Yes, what will happen here, whether there will be unique solution or what? So here the solution will exist. Okay, and you will get also the free variables. Okay, you will also get the free variable here, right? So if number of pivots are less than the number of unknowns, okay, so the pivots, the equations are consistent and you will get these solutions. Okay, but you will get many solutions, right? Okay, so these are the 3 conditions. Or sir, other than diagonal elements of a of augmented matrix, which elements are called as a pivot position in augmented? See, only pivots we have to consider this only, right? Whether you can make it whether you can make it what? You can make upper triangular matrix. Try to get standard matrix. Okay, standard matrix are upper triangular matrix, standard matrix are lower triangular matrix. Okay, so these are the so this is how we go. Okay, in echelon form we do like this only. Okay, so you will always go you will always try to eliminate first, then second, then third, right? Okay, step by step you will go now. First you will eliminate x2, then you will eliminate x3, right? Okay, so that you can find out the when you will go back, so you can find out the solutions, right? Okay, only the main concept is pivot should not be any 0 element, right? Pivot should be always non-zero one. Yes. Okay, so if I ask you how many free variables are there, guys, here we can consider now free variables because this row is entirely 0, right? So what is free variable? So see guys, number of pivot we call in matrix. Remember always, if there are number of pivots, what is the meaning of number of pivots? Number of pivots is also known as rank of the matrix. Rank of the matrix. Okay, you will come to know more important words, but here number of pivots is known as rank of the matrix, and we denote number of pivot as R, right? And number of variable, you can say number of variable we represent as n, right? So how many free variables will be there here? The free variables you can calculate now is n minus r. So this is going to be the free variables. Okay, number of free variable will be n minus r. N is the number of variable and r is the pivot, number of pivot, or you can say rank of the matrix. Okay, rank of the matrix. So only your life is very simple, guys. If you don't know about anything, just go what you have to recall your 10th standard math, nothing else. Okay, you don't have to recall anything. 10th standard math, apply elimination method. What is elimination method? Let me tell you guys, that is simple. What? That is the removing one removing one variable, finding out other variable and getting back to equation and finding another variable, right? Or you can say applying row operations, okay, so that you can eliminate elements in the matrix, okay, below the pivot, right, and find the number of pivot. That's it. Okay, so this is how we can find out number of free variables as well, right? Why we are calling it free variable? You can see the third equation is completely free. Okay, you can consider anything, any variable here, right? You can write k1, k2, whatever you want to write, right? You can consider this, okay, because everything is 0 here, right? So I hope this makes sense to everyone, and this was the important concept which I wanted to discuss, right? So for today this is enough, I think. Yeah, so let me get back to so that was the concept, guys, which I wanted to discuss, okay, for today. So in fact I have discussed many concepts today, right? You don't know about what is rank of the matrix, but still you can comment on that, right? If you see the number of pivots, right, you can say that rank of the matrix is going to be this. Okay, any number of equations, any number of unknowns you see, okay, and you can solve the questions, right? So let me take one question, very important question from you can say from from gate 2022, right? Let me take that question and I will show you that question, right? So wait for the moment. So let me bring back that question from my gallery, okay, and I think you would be able to solve that question, right? Paste here. Okay, so see here the same question which I am going to discuss, right? See, is the question visible, guys? Will you teach every day, so yes, Sumentro, if I will not be tired, and definitely I'm gonna do, right, if there will not be any power cut in Bangalore, right? So guys, you can see the question here, the very good question which was asked in gate gate 2022 in ECE paper, right? In second you can solve this kind of a question, right? It is 2 by 3 matrix, or you can say there are 2 equations and 3 unknowns, right? Sorry, how many unknowns are there, guys? You check. There are 2 equations and 3 unknowns. Yeah, I am correct, right? So options are like, let me read the options: unique solutions, infinitely many solutions, no solutions, exactly 2 solutions. It is very easy question, right? Okay. Yes, guys. Yeah, go ahead. So definitely there will not be unique solution. Can you comment on that? Why there will not be unique solution? Because the number of pivots are not equal to number of variables. You can eliminate directly the option. This option will be eliminated straight away. Never choose option A, right? Never choose option D as well. Okay. Okay, guys. Yes. Now the fight is between these two. Okay. Are you able to understand this? So this kind of question you can blindly solve with confidence. Okay. Needless to remember any coaching material. Okay. This rank of A should be equal to rank of A given B, this, that. Okay. That is time waste, purely time waste, let me tell you. If you know the basics, you can attack. Yeah. अगर आपको बेसिक आता है तो आप अटैक कर सकते हो, राइट? Hrithik is saying infinitely many solutions. Oh my god, you make the mistake, I guess. Okay, so let me do the augmented matrix here, guys. A given B. The moment you see this, because already they have given you in the form of Ax equal to B, so you don't have to find. So write this as 1 minus root 2, 3, minus 1 root 2 and minus 3. Okay, and yeah. So what you can do here is you can put this as 1, 3. Now you take this as a pivot here, right? So below this pivot you have to make it 0. So how can you make it 0? Simple, you can add these two rows, right? So it will be minus 1 root 2, 3 and 1, and it is going to be 0, 0, 0, but this will be 4, right? So the moment you see this, okay, the moment you see here, all the elements are what? There is a number of pivot, okay, it's okay. Already unique solution will not exist. Okay. Hithik yaar. Hithik, okay. Never make this kind of a blunder, 2-mark question is there, right? So never make mistake. I know, आप क्या करते हो ना, आपको मिला, okay, infinitely, because you thought that lines are, they are coinciding, it's okay. But please think about that, right? So in terms of matrix, this is after all 2 by 3 kind of a matrix, right? So this guy is a culprit here, right? Who is a culprit? In the B column, there is a culprit, right? That is non-zero. Okay, you can say there is a pivot in the right column. Okay, pivot in right column. So no solution. Okay, see why I am calling it no solution, because this equation is inconsistent, right? Again, let me tell you guys, the fundamental problem of linear algebra is to solve the system of linear equation. That's it. So if you are reducing the matrix, it means that you have to find the solution of those variables, right? So don't reduce like randomly anything, right? You have to see also if that equation after reduction, after applying Gauss elimination method, you have to keep in mind that. Okay, so this answer is correct here. No solution will exist. Okay, yeah, I think you can get 2 marks easily. Okay, let me come back again and yeah, I hope you might have enjoyed the session. So you can give your feedback for first session. This was on linear algebra, and in fact I'm going to bring more sessions, guys, on linear algebra, and you will come to know that what is the difference between eigenvector and the vector. Okay, in fact I will break all these stereotypes, like you all the time by heart the concept, right? And you follow some of the any material which is repeated, obsolete. So my main objective is to bring content on YouTube which are systematically new as well, right? So आपको अच्छा भी लगेगा, ठीक है? So I hope you might have enjoyed. Let me wind up the session here. Okay, so Hithik, have you understood? And Sumandro and Hit, okay, because this time yes, the session is very long only. Thank you so much, guys, for today, and you can comment your feedback on comment box, right? Apart from this, sir, I did not get which element you are calling as a pivot, so other than diagonal element of A matrix. Yeah, see, there is a diagonal is there, right? So you are taking one, okay, first element as a pivot, then come down, because already you have made the second row first element 0, right? So take second, then you have made again, you make it 0, right? Okay, in this manner you can take, right? So you think that you're doing something, you're trying to eliminate variables, right, from equations. Okay, the way you have done in class 10th, right? You will understand easily. Okay, Ravi Teja. So this is how we reduce, and we will discuss echelon form, like whether echelon form can be upper triangular matrix, or or any echelon form can be said to be a upper triangular matrix or not, all these things, right? So we will talk about more concept tomorrow. So thank you for today, right? Yeah, Sumandro, yeah, please teach regularly. Definitely, Sumandro. You have to share this session among everyone in your colleges, right? Students are in need, guys. They are in dire need of real knowledge. Okay, they are following very big lectures where people shout, okay, and gives no information, right? Other than the repeated notes from any coachings, right? Top coaching, I'm saying, right? So they copy from there, and yeah. So yeah, sure, Hitik, I will share the notes. That's what I'm saying. If you want notes, you can always contact me on my WhatsApp, right? So I will be sharing PDF, right? Whatever I'm teaching. Thank you. Thank you and good night. And please share this session in your college groups. That's what I want from you. Okay? I don't want anything. I just want your feedback on comment box apart from this live chat, as well as share this session in your colleges, right? Among all the branches, they are from electrical, electronics, computer science, civil, mechanical, because mathematics is universal for everyone, right? It's okay, we'll catch up tomorrow. Thank you.